Welcome to AP Daily. We will be going over topic 7.10, the reaction quotient and Le Chatelier's principle. This video will go over the relationship between Q and K once a disturbance changes equilibrium according to Le Chatelier's principle. I am Brian Preby. I'm an AP Chemistry student at Bayport High School in Green Bay, Wisconsin. First, some information to recall. The reaction quotient, Q, is the ratio of products over reactants at any point in the reaction. The equilibrium constant, K, is the ratio of products over reactants while the system is at equilibrium. Le Chatelier's principle states that if a system is disturbed, it will work to minimize the disturbance, shifting either left towards the reactants or right towards the products. The system is at equilibrium when Q equals K. So first we'll be talking about the effect of concentration change on equilibrium. So if either the reactant, which is the bottom, is decreased, or the product is increased, this will cause Q to be greater than K, meaning that there is more product versus reactant. This will cause the system to shift left in order to reach equilibrium again, going from the product to the reactant. Now, if we increase the reactant and decrease the product, this will mean that there's more reactant compared to product, meaning that Q is less than K. This will cause the system to shift to the right in order to reach equilibrium again. Now we'll look at the effect of pressure change on equilibrium. So first we must remember that volume and pressure are inversely related, meaning that if we increase the volume of a container, that will decrease the pressure. And if we decrease the volume, it will increase the pressure. So in order to determine which way the system will shift after the disturbance with pressure, we must look at the number of moles on each side of the equation. So if we increase the pressure, this will cause QP to increase. And when you increase the pressure, the system will shift to the side with fewer moles. So if we look at this example, we see that the pressure is increasing. And since there are 4 moles on the left side and 2 moles on the right side, the system will shift to the right because the right only has 2 moles. So now if we decrease the pressure, which is the right example, QP will decrease, and in this case, the system will shift to the side with more moles. Now since the left side has more moles, it will shift to the left. So now, if we take a look at the effect of temperature change on equilibrium, so unlike changes in concentration and pressure, a change in temperature will actually cause the K value to change instead of the Q. It is important to remember the 2 types of temperature changes here, being endothermic and exothermic, where endothermic is where the heat is absorbed and exothermic heat is released. So if we take a look at endothermic, since heat is absorbed, we can view heat as a reactant. Now, in this case, so since we're looking at heat as a reactant, we can treat it similar to concentration. So if we increase the temperature, there will be more reactant, meaning the system will shift to the right. If we decrease temperature, there will be less reactant than product, meaning that the system will shift from right to left. Now, if we take a look at the exothermic, now since heat is released, we can take a look at this one as product. If we increase the temperature, this will cause the system to shift left, and if we decrease the temperature, this will cause it to shift right. Now, when the system shifts right, K will increase, and when it shifts left, K will decrease. Let's take a look at an example problem. The equilibrium reaction between Cl2 and H2O at 25 degrees Celsius is represented by the chemical equation shown above. If a solution at equilibrium at 25 degrees Celsius is diluted with distilled water to twice its original volume, which of the following gives the value for QC and predicts the response by the system immediately after dilution? Go ahead and give this one a try. The correct answer is D. QC equals Kc over 4, and the rate of the forward reaction will be greater than the rate of the reverse reaction. Now, taking a look at this problem, we see that since whereas distilled water makes the volume twice as large. Now, you may be thinking this one could be a pressure problem. However, this one is a concentration problem. And since there is twice as much volume with the same amount of products and reactants, everything will be halved. So that is where we get this bottom. We can put the 1/2 coefficient in front of all of the molecules, giving us our Kc over 4. And now, since in this case Qc will be less than Kc, the forward reaction will be greater, giving our answer a B. A little recap. Le Chatelier's principle states that if a system is disturbed, it will work to minimize a disturbance, shifting left or right. These disturbances include change in concentration, pressure, or temperature. During equilibrium, K equals Q, and when the system is out of equilibrium, K will not equal Q. A change in pressure and concentration will cause the Q to change, and change in temperature will cause the K to change. Thank you for watching.